All right, so today we begin a discussion of what are known as the conic sections. And so you probably see the word cone as a root word for conic. And here's what we mean by the conic sections. There are 4 of them that we're going to study in detail. And the reason why they are called conic sections, and here's some good illustration of that. If you take what is known as a double nap cone, where the ends of the cone are put together like you see pictured here, and you take what is known as a plane, or you can think of that as a flat surface, and you slice through the cone at particular angles, or in the case of a circle, no angle at all, you create these shapes. And the shape that we're going to focus on today is the parabola, and this is how it's made. As you can see, the cone or the plane being angled, and we're only slicing one part of the double nap cone. And you can see that when that happens, the parabola is formed. And we've already looked at parabolas as the graphs of quadratic functions. So we're just going to take a more in-depth study and talk about some other parts, other things that are used to actually form a parabola. There's actually 2 different mathematical entities that we're going to discuss that help us when creating a parabola. So I just want to walk through this as an example. Here is the graph, the parabola, the graph of the function y equals 1/8 x squared. Well, this is just another way of looking at how a parabola is made. A parabola is really formed by 2 different math entities working together. And those entities are a fixed point, and that point is called the focus. So I'm going to use this slide to throw some terms at you. Here's the deal about the focus. It's always a point, obviously. It's always inside, always refer to it as inside the mouth of the parabola. Its position is always inside the parabola. That's kind of important when we're going to look at some other problems later where we have to come up with the equation for the function knowing where the focus is. It tells us a lot about how a particular parabola opens. So the focus is always inside the mouth. So in addition to the focus, there's this other math entity known as the directrix. And the directrix is a line. And in this particular case, it's the line y equals -2. Now, hopefully by the end of today's lesson, you're going to understand why the focus is the point 0,2. And you're going to understand why the directrix is the line y equals -2. But right now, I just want you to understand the focus is a point, always inside the mouth of a parabola. The directrix is a line. And the thing to keep in mind is the vertex of the parabola should sit right in between those 2 things. If you notice, the vertex is right in the middle of that point and that line. So the technical math-ese definition of a parabola is this. It's all the points in a plane that are equidistant. Pretty easy to understand what that means. Equidistant from a given point, called the focus, and a set line, called the directrix. So here's what I mean. If I take this distance, it should be the same from focus to parabola as it is, and my parabola is not exactly right, but hopefully you get the picture. Those 2 distances should be the same. And if I keep doing that forever and ever and ever, that distance, and I put a point right in between them, that's another point on the parabola. It's all the points in a plane that are the same from this ordered pair called the focus to this line called the directrix. All of those points that can be formed when I look at basically the union of this point and this line. That is the definition of a parabola. Our job is to get familiar with what basic equations for parabolas look like, and by the end of today's lesson I want you to be able to take information like where is the focus, where's the directrix, now how do we come up with the equation of a parabola. Well, let's start first of all with some parent equations. These are good to get used to. Here I'm illustrating just a parabola that opens up, and all of these have vertex at the origin. So the basic parent equation or function that represents this is y equals x squared. Remember, parabolas always have to be quadratic equations or functions. When the parabola opens down from the origin, we've talked about this a little bit when we talked about reflections. That just means that we put negative in front of x squared. So when the quadratic function is solved for y, my parabola has to open either up or down. And if negative is in front of the x squared, obviously it's got to open down. When the parabola equation, the quadratic equation, is solved for x, then the parabola has to open either right or left. So here, the equation to represent this graph for the parabola opening right would be x equals y squared, and when it opens to the left, it just makes it negative y squared. Okay, those are parents. Parents mean that the vertex in every case is at the origin. All right, so with that said, let's get into some specific examples of homework problems. There are 4 problems on your assignment that look a lot like these 2 examples. Okay, this is really wordy. I'm going to read this just like it comes from the sheet that I gave you. Write an equation for a graph that is the set of all points in the plane that are equidistant from the given point and the given line. What did I just read? That is the definition of a parabola. Remember I gave you the illustration? So what they could have said is write the equation for this parabola with this given information, but they decided to use the actual definition of what a parabola is. What we know about this parabola is that it has a focus. That's what this capital F means. The focus is located at 0, 3. So for this first example, you don't have to graph these, but I'm just going to do a little rough sketch just to give you a picture, and then I think you'll see what to do from this point forward. So let's just say here is 0, 3. And here is y is negative 3. I got the focus and I got the directrix. What do I know about the vertex? If I know the focus and the directrix, where should the vertex be placed? Right in between them. So in this particular case, where would you say the vertex is? The origin. Okay, so I'm going to draw a rough sketch parabola that shows vertex at the origin. Why did I show it opening up? Why not opening down? How did I know that this parabola opens up? The focus is positive, and where's the focus always located? In the mouth of the parabola. So now you're getting a picture. If you know where the focus is, then you essentially know how the parabola opens, and now you know which of these 4 basic equations to work with. We know that our answer is going to look something like this. Okay? What we're going to have to do is come up with the actual number. Right now the coefficient is 1 for the parent. We're going to come up with the actual coefficient for x squared using a formula. Here it is. For parabolas, you wear this formula out. The absolute value of A is referring to this number that sits in front of x squared or y squared. The absolute value of A is equal to 1 over 4c. We know what A is. Here's what C refers to in this formula. C, and I'm going to write it on this first example, C is the distance. And it always, for parabolas in this formula, it always refers to the distance from vertex to focus. Or you could say vertex to directrix because they're the same distance away. But the definition of what C literally means, if you were to look in a math textbook, it would probably say distance from vertex to focus. What is that distance in this problem? 3. So C is literally the number 3. Now I know what A is. What's A? 1/12. Okay, so I started off with a y equals some number that has to be positive because this parabola opens up, x squared, and now I basically know what to fill in the blank. 1/12 is my answer for A. A is always the coefficient of either x squared or y squared. And so that would be my answer for example A. Any questions on example A? Okay, get really familiar with this formula. It's easy. It's used a lot. All right, letter B. What do I know about how this parabola opens? The focus is on the negative x-axis. I'll just put a little random dot here. I'm going to call that negative 1/4 0. So how does this parabola open? Okay, it opens to the left. So I'm starting off already. I know that my equation to represent this has to be x equals negative some number that we're going to use our formula to find, y squared. Okay, now I'm going to go back to this formula and I'm going to find out what that number, that coefficient for y squared is. So I'm literally just going to fill in the blank. The absolute value of A, that's the number I'm looking for, is equal to 1/4c. What is c in this case? Now remember, c is not direction, it's just distance. How far is it from the vertex to the focus? 1/4 of a space. So I'm not going to plug in negative 1/4. I just want to know how far apart are they. So when I let c be 1/4 and I calculate this, what is A? A is 1. Now, I already know that this coefficient has to be negative because of the way the parabola opens. The number that comes out of this formula because of absolute value is always a positive number. Okay, I don't want you to be confused. The thing that makes this overall equation negative is because the parabola opens left. So I literally, you don't even have to have 1 here, but I'm going to go ahead and put it just so you can see that it came out of using this formula. So the good answer would be x equals negative y squared. Any questions? Does that make sense? Pretty easy? Questions at all? Okay. A lot of what we're going to do from here on out is using that formula. Based on what we're given, we're going to either find A or we're going to find C. Okay? Let's see what we're going to have to work with here. We're going to write an equation for a parabola. We're told that every one of these have a vertex at the origin, and they're going to tell us where the focus is. So Reagan, for letter A, how does this parabola open? Up, down, left, or right? Where is 5, 0? Like if you were to plot 5, 0. There? Okay, so if 5, 0 is here and the focus is always in the mouth, then we must have a parabola that opens to the right. And so you're going into your index of functions and you know that you're dealing with this as a general function. All you have to do is find out what the coefficient called A is. Okay, so once again, use your formula. Absolute value of A is 1 over 4C. And Lakin, what is C in this case? 5. So A is 1/20th. And that's my answer. Okay, we'll just do letter B, and I think you get it. We can skip letter C. Camden, how does the parabola open for letter B? Opens down. So the general equation form that I'm going to use would read as what? Okay, y equals negative A, some number called A, x squared. All right, so I'll give you a few seconds if you haven't already. Find out what A is. So Matthew, give me the overall equation to represent the graph of this. Very good. Any questions? It's a good lesson to come back to after the break? I thought so. Okay, we'll skip letter C. We might be able to skip this one as well. It's the same problem, just given in different words. When they say in this problem that the focus is 2.5 units from the vertex, they've identified what letter in our function, in our formula. They've told us what C is. So once again, you can plug that in. They already told you that the parabola opens upward. So Johnny, in general, what does that equation look like for any parabola that opens upward and has a vertex at the origin? Okay. And I'm going to go ahead and throw in that little a. I know our parent function's a is always 1, but in these you're going to be finding the number called a, and it will not be 1. And again, you're going to use your formula to do that. Okay, so to save a little bit of time, I'm just going to fly through this. Any questions? The only thing I would caution you with is, I don't know if this happens, but make sure you don't give me any complex number values for A. Complex fractions is what I mean when you use your formula. Okay, now the problems get a little different. This is 16 to 23. Given a function that represents the graph of a parabola, can you find the focus and the directrix? Okay, well let me give you a tip about functions, quadratic functions. When you do not see any addition or subtraction, like in letters A and B, do you notice that nothing is added or subtracted? Everything is multiply. I know we have this power, but we don't have any addition or subtraction. That's a clue that you have vertex at the origin. When there are no addition or subtraction symbols, then it's always going to be true that you're dealing with a parabola whose vertex is at the origin. Okay, so let me go to Cooper. In letter A, how does this parabola open? Opens up. Okay. I'm going to go to my formula, but this time notice I'm given A. I'm going to use that same formula as I used before, but this time I need to use the value of A in order to find C. I'm going to plug 1/24th. And if you can't see it, sometimes they're a little more challenging than this. You can always do cross multiplication to solve for C. Just let the two products equal each other. This one you probably didn't have to do that, but I'm going to do it anyway. So I know C is 6. Okay? A mistake that some people make at this point is they just tell me the focus is 6. Well, the focus is an ordered pair. And I'm starting at the vertex being at the origin, and I'm going to travel this many places in the direction that the parabola opens. So Sydney, I'm at the origin. I travel 6 places up. Where am I? So my answer for focus, I'll just put a little F here, is the point 0, 6. And what about the directrix? Gauge? What do I know about the focus and the directrix in relation to the vertex? Same distance apart, just in the other direction, and it's a line. So the line, if I go down 6 and I draw a horizontal line, it would be, well, it's going to be a line, not a point. So the equation for a horizontal line would be y equals -6. So let me give you a little piece of advice about the directrix. It is always a line, it's never a point. If your given equation says y equals, the directrix should say y equals. If the given equation says x equals, then your directrix should also say x equals. All right, Katie, how does letter B open? Okay, now let's find out what C is so we can know how far to travel to the right until we get to the focus. Have you found it? What is it? C is 2. Everybody see that? For letter B, using that same formula. So Katie, I'm traveling 2 spaces to the right from the origin, and I'm at what point? Okay, so the focus is 2, 0. And Matthew, what would the directrix be? X is -2. Any questions? Everybody good so far? Okay, it's not until you get to this part of your assignment that you're going to start actually graphing. And okay, so your instructions say to find the vertex, focus, and the directrix, and then sketch the graph. All right, let me give you another heads up. If you don't have an equation that is solved for a variable, then you need to do that first. And how do you know which variable to solve for? Well, it's always the one that has the lower degree. All right, I got 2 variables in this equation. X is to the second, y is to the first. I'm solving for y. You always solve for the variable that's in the lower degree. And just turning this around, solving for y, I would be multiplying by 1/8 on both sides. I get y equals 1/8 x squared. Okay, now I'm ready to take off and answer all the different parts. I don't have any addition or subtraction in this function, so that always means the vertex has to be at the origin. We already learned how to find the focus and the directrix, so using your formula, and in this case, it's probably pretty easy to tell what C is. What is C? C is 2. I'm going to travel 2 units from the origin in which direction? How does this parabola open? It opens up. So I'm traveling 2 units up, and that puts me at 0, 2. So what's going to be the equation for the directrix? Y equals -2. And now it's just a matter of putting everything together and sketching the parabola. We're not going to go crazy with a lot of points. I just want the vertex and then really 2 other points, one on either side of the axis of symmetry. I do want you to plot focus and directrix. So here's my focus. Here's the directrix. It's not plotting the directrix, you draw it. And then let's just come up with 1 point, and then we can match it. It's a good input. 2. If you input 2, what's the output? 1/2. 2 squared is 4. 4 times 1/8 is 4/8, or 1/2. So 2 1/2, which means -2 1/2, also on there. And here's our graph. I'll give you a little help here that might make your graphing a little bit easier. Let's see if you can make a connection. Do you notice that from the focus, now it's always in relation to the focus, this is a total of 8 units between these points, or another way of looking at it is from focus to this point is 4 units. What's a quick and easy way to get 4, or a total of 8 between these 2 points on the same line as the focus? Do you see it? Do you see something in the function that might be a clue? See that 8? So that always works. If you just take the number 8 and split it, and again, you're plotting from the focus, you can just go to the right and to the left, basically half of 8, and you can get more points that way. Just a suggestion. I mean, some of the numbers are obviously easier to calculate than others, but it does work. Okay, let's try this one. I'm not solved for a variable, so that needs to be first step. And I'm going to be solving for y because it's the lower degree. And when I solve for y, I'm going to be multiplying by a 4th. This should look familiar to you. Vertex form. So what's the vertex? Very good. Vertex is -3, 0. We find the focus, at least the number, the same way. So let's see if we can find out what c is. Absolute value of a, which is 1/4, is 1 over 4c. So what's c? C is 1. Okay, so be careful. Up to this point, everything's been centered at the vertex has been at the origin. Well, this time we have a vertex of -3, 0. And we're traveling in the same direction that this parabola opens, which is up, down, left, right. Well, it's solved for y, so it's got to be up or down. When it's solved for y, it's got to be up or down, and if a is positive, then it means up. So from the vertex, I'm going to travel c places upward, and that puts me where? So the focus is the point -3, 1. What's the directrix? Y equals -1. Okay, I take the 4 and I split it in half. I get 2, obviously. So from the focus, I can put a dot 2 places to the right and 2 places to the left. And that's it. Any questions? Okay, I need to get to some that are a little more challenging. Okay, so what we have here, it is going to be a parabola because I've got 2 variables, but one of them is first degree, the other one is not. So remember changing to vertex form using completing the square. That's coming back. Okay, so the variable that is second degree, which is x, I'm going to be completing the square on. You always complete the square on the higher degree variable. So to get this set up, I'm going to put my x terms on the left, and I'm moving everything else to the right. So I'm preparing to complete the square on x. So when I complete the square, in the parentheses I would have x plus 3. See where I got 3? 6 divided by 2. Okay? So what I've essentially done, if I were to square this out, it would be x squared plus 6x plus 9. I have essentially added 9 to the left side of this equation. So what should I do to balance it out? Add 9 to the right. Everybody get that? If you were to literally write this out squared, there would be a plus 9 there that wasn't there originally. So to get this in completing the square form, we've added 9. So to balance out the equation, I need to add 9. And then we're just solving for y. Remember, you always solve for the variable that's in the lower degree, so you would add 3 to both sides. And now I'm going to divide or multiply. You can think of multiplication by negative 1/3 on both sides. And be careful here because you also have to multiply this number not in parentheses by negative 1/3. Now we're ready. What's the vertex? -3, -1. It's in vertex form. Okay, I'll give you a minute and see if you can find the focus. Find C using your formula. Did you get 3/4? Okay. How does this parabola open? It's solved for y, so it's got to be up or down. It's going to be down because the a number is negative. So that represents a maximum. We're going to be opening down from here. So to get to the focus, this time I'm going to travel 3/4 of a unit, but I'm going down from there. So if I'm here at -3, -1, and I go down 3/4, where am I? What's that ordered pair? Well, it's -3 and -1 3/4. Or you could have put -7/4. Everybody catch that? So you remember the focus always goes inside the mouth of the parabola, and you travel C places in the direction that the parabola opens from the vertex. Okay, what does that make the focus? So this time from the vertex I'm going to go 3/4 of a unit upward and draw a line. And if I do, that would be the line y equals -1/4. Did I lose anybody? Everybody still good? Any questions? Yeah, go ahead. Okay, so back to this problem. We have found the vertex, the focus, and the directrix, and now it's just a matter of finishing this off. You can always take this number in the denominator, in this case the 3, or if you wanted to go back and look at it in this form, the number in front of y, which is -3. The negative really doesn't matter, but if you're looking for an easy way to get other points, just in this case take 3 and divide by 2, and that's 1 1/2. And so I can move 1.5 places from the focus. Now remember, that's from the focus. 1.5, just stay on that same line as the focus is on. And I can make a dot there. That's on the parabola. And then the same thing going in the other direction. That point should also be on the parabola. And so here is my graph. Again, just the vertex and 2 other points will be sufficient. And then go ahead and plot the focus and the directrix. Okay, let's try this problem, which matches up pretty closely to your number 35. This time, I noticed that y squared, I'm going to be completing the square on y, so I'm going to put my y terms together on the left side so that I can set up completing the square, and then the x term and the constant is going to go to the right side. So I added 4x and subtracted 16. Complete the square on y. I get y minus 2 quantity squared. And again, since I've essentially added 4 to this left side, when I square this out, I'm going to get y squared minus 4y plus 4. So to balance the equation, I need to add 4 to the right side. And when I add 4 to the right side, I get 4x minus 12. And now I'm going to solve this for x. And so add 12 to both sides. Multiply by 1/4 on both sides. Don't forget that includes multiplying 12 by 1/4. Now this one, when it comes to vertex form, you have to be careful. It's a little tricky when the equation, the quadratic equation, is solved for x. Just keep in mind that in the parentheses we have y coupled with 2. So this is a clue for you. Typically, vertex form that we've looked at in the past is solved for y. I get my x coordinate from the parentheses, thinking opposite, and my y coordinate is this other number. Well, you can probably imagine that when it's solved for x, it's just the opposite of that. It's the reverse of that. The y coordinate is going to come from the parentheses, and the x coordinate is going to be this other number outside the parentheses. I still have to be careful to do the opposite when I'm coming up with this number, this coordinate for the vertex that is coming out of the parentheses. It's actually going to be positive 2. So be careful when your quadratic equation is solved for x. So this should be a parabola that opens to the right from the point 3, 2. Okay, so I'm going to go ahead and plot 3, 2. And let's come up with our focus and directrix. If we do the absolute value of A is 1/4c, that makes c is 1. And since this parabola opens to the right, it's solved for x, and the A number is positive. That means that I'm going to travel one place to the right to get to the focus. So let's just summarize our answers over here. Vertex is 3, 2. Focus then is going to be 4, 2. Just moved one place to the right. And the directrix is going to be a vertical line this time. It's going to be the vertical line x equals 2. Okay, and then my little trick on finding 2 other points, I just take 4 and divide it by 2. And once again, be careful. You're always in relation to the focus when you're coming up with these points. And this time I'm going to go up and down 2 places. Okay, so here's my focus, this blue dot. Half of 4 is 2, so I'm going to go up 2 from the focus and down 2 from the focus, and draw through those points. And I've got my parabola and all the information that was required. Okay, so that takes care of this lesson. If you go to RenWeb in the lesson plan area, you will see this link where you can just click on this link, and then you'll see, I want you to do these problems. But again, it's in RenWeb. It's a little different than what we've done in the past. Obviously, this isn't in your book. So go to RenWeb, look for the lesson plan area where you typically find your homework. And I think it's actually called lesson plan in your section of RenWeb when you pull it up. And you should see a link called this. Click on it, and then it's a document. And then I want you to do these problems off of that handout. Okay? If you have any questions, let me know.